Turn the light on. 2 videos. Okay. One of the last theorems we're going to go over is the vertical angle theorem, which we covered already, correct? What are vertical angles? We've gone over this. They're what? Yeah, I mean, what do we know about vertical angles? There's a picture of it right here. They're what? They're equal to each other. So angle 1 and angle 2 are equal to each other, right? 3 and 4 are equal to each other. So that's stated here. Those are vertical angles. Vertical angles are congruent, equal to each other. Perfect. Right there in the definition for us. A linear pair, the linear pair postulate, supplementary postulate basically, says that if the two angles form a linear pair, then they add up to 180. A linear pair means they share a ray and the other two sides are opposite rays. See how this one goes right and this one goes left? So they share a ray, they share this ray. The other two are opposite rays. So I know that these two add up to 180. That's a linear pair supplementary. Okay, we are going to prove the vertical angles being true. I've actually showed you this before too. So let's start with the given. Let's write down the given. We're going to prove these equal to each other without using any numbers basically. So angle 1, angle 3 are vertical angles. Sorry, thank you. This is given. Angle 1 and angle 3, these two are vertical angles. What do we know about angle 1 and angle 2? What kind of angles are they? Yes, correct. They're a linear pair. They're supplementary. So let's write that. Angle 1 and angle 2 are a linear pair. We know this by the definition of linear pair. We know this because they fit the definition. So I know that angle 1 plus angle 2 equals how much? Oh my gosh. Oh, we got donuts.
Hi, this is for Mr. Stairs. I just want to thank you for being a teacher.
Ooh, thank you.
You're welcome.
Sorry, guys. It smells good. So what does angle 1 and angle 2 add up to?
You should learn how to split it among.
You're a math teacher.
Yeah.
Can you prove it? Oh, that's a bummer. You haven't taught until they have learned. So what does this add up to? What does 1 and 2 add up to?
180.
We know this because of this postulate. I know that these add up to 180 because of this postulate right there. It says right here what they do. They add up to 180. So linear pair postulate. So there's a difference. I know these two are a linear pair because they fit the definition of a linear pair. The physical angles fit the physical definition. I know that they add up to 180 because of the postulate, not because of the definition, because of the postulate. Remember, the definition only states that they share a ray and they have opposite rays. That's the definition. It says nothing about 180 in the definition. But in the postulate, it talks about adding up to 180 degrees. That's why this is now the postulate. So I know that these two are a linear pair and they add up to 180. What do I know about 2 and 3? The same thing. So we're going to write the same thing down. Angle 2 and angle 3 are a linear pair because they are, or they fit, the definition of linear pair. You could also be writing supplementary. You don't have to use linear pair. So since I know they are a linear pair, I can say that angle 2 plus angle 3 equal 180. This is because of linear pair postulate. Again, I'm going to keep showing you, referring you back to these writings right here. You don't have to memorize them, just know what they speak of. Sorry, you can't see it up here. All right. So what do I know? I know that these both equal 180, correct? So correct me if I'm wrong. If they both equal 180, shouldn't I be able to write them equal to each other? Wouldn't that be true if they both equal 180? Okay. Okay, what did I use to do that? How did I set them equal to each other? If they both equal something and I kind of took one out and put something else in. Substitution. I have two statements where they say they equal the same thing, so I substituted out 180, plugged in angle 2 plus angle 3. Okay, I have a number on the same side, and I added two different things to each of them, but they equal each other. Ooh, more stuff. Thank you. Here. So what does this look like? If we flip back, and I want you to flip back, which one of these properties do we see going on? Not transitive. I'm adding the same thing to both sides, right? I'm adding angle 2 to this side, and I'm adding angle 2 to this side. I have two different things, but I'm adding the same thing to both sides. Keep saying the word over and over. Addition. Addition. I'm adding the same thing to both sides. So I know because of adding angle 2 to the left and angle 2 to the right, angle 1 is equal to angle 3 by the addition property. What I mean by this is if I was to subtract 2 from here and subtract 2 from here, I'm left with angle 1 equaling angle 3. This is the addition property. Done. Proved it. Turn the page. So that was supposed to blow your mind that you know physically those are congruent without even having an equation. You just use letters. Or those word numbers, but technically letters. So what do I do here? Find the value for x. What do you know about those things? They're equal, so then what do I do with them? Correct. Set them equal to each other. Okay, you don't need to justify these steps, just solve. So subtract 2x on both sides. Subtract 14 from both sides. Right? Minus 2x, I get x. Minus 14, I get negative 4. Cool. Okay, find the values for x and y. So what do I know about these? They're equal, okay. 2y equals 7x. Okay, I can't solve for either of them because there's two of them. You have to have one variable to be able to solve. So what do I know about those two? They equal 180, but what do I have to do to them to equal 180? Add them. Okay. Glad we don't have any atoms in this class. So 2y plus 9x plus 20 equals 180. Perfect. So I look like I have a 2y here and a 2y here. And 2y is equal to 7x. Substitute it. This shows up twice. And I know that 2y is the same as 7x's.
So 7x plus 9.
Yeah, so 7x plus 9x plus 20 equals 180. Right? If it says 2y equals 7x's, then I can trade one in and out for the other. So I traded out 2y for 7x. I don't want no x or no y's. Okay, so 16x plus 20 equals 180. The inverse of adding 20 is to subtract it, so I subtract it on both sides. 16x equals 160. Divide by 16 on both sides. X equals 10. So now I know what x is. What can I do with this x? Plug it in. We're going to substitute this back into this top equation. So 2y equals 7 times 10. So 2y equals 70. What do I do here in y? But why am I dividing by 2? It's the blank of, it's the inverse of multiplying by 2. So y equals 35. Okay, I'm trying to build this idea.